Councilman Ron Roberts proposed construction of SkyTram running from downtown San Diego to Balboa Park. The SkyTram is to act as a method of alleviating traffic as well as serving as an attraction for tourists of the city. Prior to the start of engineering and design of the tram, a constructability analysis will need to be performed to determine the feasibility of such a project and to raise any issues during the process. The following disciplines were taken into account: layout and mapping to determine the best locations for the columns and the landing sites, geotechnical analysis to provide reports and directions on the existing soil conditions, a structural analysis to provide preliminary studies and recommendations on the foundation and column designs, a transportation analysis to assess the current traffic flow and determine the effects of the SkyTram, an environmental analysis to provide an environmental impact report and advise of any mitigations that must be followed during construction, as well as a constructability analysis to determine the overall cost and duration of the project.
The proposed route travels from a landing site at 5th Avenue near Petco Park all the way down 6th Avenue and then cuts across the freeway and into the heart of Balboa Park at an area just north of Spreckels Organ Society. Each column location was determined by considering the limited land available downtown and what sort of changes would need to be made in order to accommodate them. Only 3 of the 7 columns have special considerations to be made. The column at G Street would need to be built in the road, which would create the need for a temporary traffic merge at this point. To accomplish our design strategy, a 400-foot column would need to be built at A Street in order to rise above the 365-foot buildings to the south. The President's Way column would be directly under the flight path coming from the San Diego airport. However, this would not be an issue because your typical plane has a flight angle of 7 to 9 degrees, which easily clears the 2.4 degree flight angle needed to clear the 800-foot tower. The cable we selected for the design is a full-locked coil rope. The track consists of 2 track cables running in each direction with a single haul rope to move the cable cars. The track cables are both 2 inches thick with a design load of 370 kips. The haul rope cable is slightly larger and has a design load of 452 kips. This cable would run approximately 9,850 feet in one direction. Approximately 60,000 feet of total cable would be needed. The cable car we decided to use for the design is designed by Gangloff Switzerland, which has a 79-person capacity and weighs 12 tons. The load capacity is 13 tons. 4 to 6 cars would be needed on the loop in order to transport 2,400 to 3,600 people per hour.
The geotechnical aspects of this project that we considered included conducting an area geology investigation, a fault investigation, and completing a geotechnical report. The investigation of the area geology included determining the soil and rock classification, as well as determining the bearing capacities and lateral forces. The fault investigation included performing a ground motion study and conducting a fault hazard assessment. The geotechnical report included testing, reviewing, and interpreting subsurface investigations, and preparing a report with findings, conclusions, and geotechnical recommendations. In the geology study for this proposed route determined the soil rock classification of the area is underlain by old peralic deposits, with the exception of the area around Petco Park, which is composed of dredged bay deposits, which happen to be liquefiable soils. For these soils, the bearing capacity is estimated at 2,000 pounds per square foot, based on minimums of 12 by 12 inch continuous footings. In performing the ground motion study and assessing fault hazards, we used studies that were done previously by industry professionals, since the entire area around the proposed route contains some kind of infrastructure. The geotechnical report concluded that the project was feasible since there was no findings to prove otherwise.
The purpose of the structural analysis report is to determine if the aerial tram can be designed logically in the scope's pathway in order to complete a structural frame, which includes columns and footings that can be placed over the pathway. Each column of the structure has to be designed for the load of the tram cars and the capacity determined through the assistance of Balboa Park traffic. The spread footing design has to be able to withhold the weight of the dead load atop and has to be designed for the geotechnical issues of liquefiable soils in the downtown area of the tram pathway. I created a free body diagram of the columns used in the frame based on the Portland aerial tram ideas and some original ideas. Calculated the total weight, horizontal force, tension of cable, and horizontal moment. Also designed spread footing in the liquefiable soil of the downtown area, which calculated the depth of footings, steel reinforced concrete piles, and the diameter.
The purpose of the traffic analysis report is to determine if the project will alleviate traffic and to recommend any detouring during construction, and after calculations, the average weekday traffic volume for 6th Avenue was 24,700 vehicles as shown in the table. Data collection were taking place in the following intersections on 6th Avenue in downtown San Diego: J Street, G Street, C Street, A Street, President's Way, El Prado, Balboa Park. And the data calculated included time, vehicle speed, standard deviation of mean, and the accuracy. The level of service of 6th Avenue, after determining the calculations, it was set to be a level of service of C, which is stable flow with acceptable delays. The first traffic detouring is during the construction of the column on the intersection of G Street and 6th Avenue. The column will be built on a parking structure which will not require any lane shutdowns on 6th Avenue and will not have any impact on traffic. The second detouring recommendation is on the intersection of 6th Avenue and G Street. The shutdown of 2 lanes and the column will be permanently built on 1 lane, which traffic control will needed. On the intersection of 6th Avenue and C Street, the column will be built on a sidewalk, and that will require a close down of 1 lane and a sidewalk, and that will cause minimal traffic delays. The second intersection of 6th Avenue and A Street, this column will be built on a plant area, will only require a close down of 1 lane for traffic to detour. On the intersection of 6th Avenue and Interstate 5, the column will be built on undeveloped plant area, which will cause a closure of sidewalk and of 1 lane. Traffic will need to be merged. On the following column, it will be on Interstate 5 and 163, on the use of land between freeways. No lane shutdowns will require and no traffic delays. The next column will be built on President's Way. It will be built on a grass area, so no traffic delays will occur. The SkyTram will not have any negative impact. The level of service of the 6th Avenue will change from level of C to a B. It will have a positive impact by having a travel time of 8 minutes, and it will increase tourism, and it will carry 4,000 to 6,000 passengers per day.
The purpose of an environmental impact report is to determine any effects on the surrounding environment and to provide proper mitigation measures to reduce the significance of those effects. EIRs are important for feasibility studies to help with the decision-making process. The following slide has our main concerns that were found after our EIR was constructed. First, with our traffic, the public must be informed of the construction and encouraged to take alternate routes to avoid heavy traffic. With noise impacts, proper mitigation measures must be taken during construction to reduce noise impacts on the surrounding community. Our biological resources could be affected during construction. Therefore, all construction crews must be aware of any endangered species in the area during construction. With public utilities, maps of sewer and water lines must be consulted to assure all pipes can be redirected if they need to be.
Due to the maximum allowable sloping of the tram cables, the downtown landing site will need to be a minimum of 150 feet above the ground. As a result, we propose constructing a 10-story building that will include a rooftop landing zone. The 53,070 square foot building will have a $57,567,000 construction cost and will take a total of 19 months to construct. Like the downtown landing site, the Balboa Park landing site will require a minimum height of 30 feet above the ground. As a result, we propose constructing a 3-story building with a rooftop landing zone. The 9,918 square foot building will have a total of $4,146,000 construction cost and will take a total of 8 months to construct. The column foundations and the columns themselves were a bit difficult to calculate for. The structural design of the column foundation was designed for the largest column in mind, and therefore the 39-foot depth will remain constant regardless of the height of the columns. However, the height of the columns do range from 80 to 400 feet, and the cost and the construction duration will have to take the differences into account. The construction cost of the columns will range from $1,800,000 to $3,600,000, and the duration will range from 10 months to 17.5 months, with the larger columns incurring the higher cost and longer durations. In summary, the total cost of construction will be $80,603,608. The assumptions made in this portion of the project is that prevailing wage will be in effect, minor utility relocation at Balboa Park will be required, and moderate to major utility relocation downtown will be required. Construction will be awarded as a CM at-risk basis, and individual parts will be delegated out to multiple general contractors as the construction manager sees fit. Easement cost for acquiring land downtown was approximated at $411 per square foot. Construction will begin on the downtown landing site and the Balboa landing site simultaneously, possibly by the same general contractor. The columns will be to follow and will be staggered pending material availability and manpower. As a result of a constructability analysis, we determined that the construction of a SkyTram running from downtown San Diego to Balboa Park is in fact feasible. We found that while the SkyTram will have the potential to alleviate traffic along 6th Avenue and downtown, the current traffic flow and level of service is adequate enough to the point where the improvement will be insignificant. However, due to the SkyTram being designed to be higher than the buildings along 6th Avenue, the cars will offer an unobstructed view of the coastline, making the SkyTram a viable tourist attraction.